Welcome to the video demo of Big Monitoring Fabric Public Cloud for AWS by Big Switch Networks. We'll start with a brief overview of AWS Networking and look into visibility challenges that customers face as they move their workloads to public cloud environments. We'll then show how Big Mon Public Cloud provides enterprise-like flow-level visibility for AWS before jumping into a demonstration showing the simplicity of Big Mon Public Cloud deployment in terms of setting up Big Mon in the cloud, customers' VPC and workload discovery, policy configuration for monitoring customer workloads and enabling flow-level visibility for customer workloads in cloud. Finally, we'll talk about Big Switch Network's multi-cloud directory offering and how it provides a single pane of glass for organization-wide hybrid cloud deployments. With that, let's briefly talk about AWS networking. When one or more instances are deployed in AWS, one needs to select which subnet it should belong to, like Web Subnet, App Subnet, or the database subnet. These subnets are logically separated from each other. Each subnet belongs to a dedicated availability zone. Availability zones are isolated locations within AWS regions which become available to the user once Virtual Private Cloud or VPC is created. VPCs are virtual networks within an AWS account that spans across all availability zones within a region. As organizations migrate to public cloud, they have been challenged to get flow-level visibility for their cloud workloads. For example, inter-instance traffic within same subnet, traffic across availability zone, external traffic, as well as VPN traffic. Note that flow-level visibility for enterprise workload leveraging taps, span ports, and network packet broker have been around for years, simplifying organizations' visibility and security operations. So how can organizations extend this visibility to AWS? Let's see how Big Mon Public Cloud enables flow-level visibility in AWS, whether it be a single instance within a VPC or multiple VPCs. When a Big Mon Public Cloud solution is deployed, a dedicated monitoring VPC is created within the user account. This monitoring VPC consists of Big Mon controller and CloudLight VX virtual switch residing in the Big Mon subnet, as well as a tool subnet is created where all the tools reside. Now let's see how this is on our Big Mon Public Cloud GUI. Within a monitoring VPC, 3 instances are deployed: CloudLight VX Virtual Switch, Big Mon Controller, and a tool instance. CloudLight VX Virtual Switch and Big Mon Controller are residing in the same subnet. Once the user has entered the account credentials, Big Mon Controller will pull the inventory, for example, workloads, VPC, and tool information for the entire account, thus enabling visibility into all the workloads in the account. Navigating to the cloud page, we see that we have visibility into all the VPCs, subnets, monitorable instance, and tools in the user account, giving users centralized single pane of glass management. VPC inventory consists of all the VPCs within the account. For each VPC, we can see the VPC ID, CIDR block used, subnet count, and monitorable instance count. For monitoring VPC, tool count, controller, and vSwitch count is displayed. If we drill down into one of the VPC, we can see the workloads and their attributes like workload ID, image ID, and which subnet it resides on within the VPC. One can see all the workloads and their attributes for the entire account in the table here. This is similar to how it would be displayed on the native AWS console. Finally, Tools table displays all the tool instances that reside on a centralized tool subnet. Now, to gain traffic visibility into a desired workload, a policy needs to be created. When a policy is created, the controller will create a VPC peering between VPC where the workloads reside and a monitoring VPC. Next, the controller will check to see if the CloudLight AX agents are installed on the workload to be monitored. If not, the controller will automatically install the CloudLight AX agents. The controller will then push the policy configuration to CloudLight VX Virtual Switch, where packet forwarding decisions are made. Before I show policy creation via GUI, I will start ping between 2 workloads. As you can see, here is the ping request and reply on the workload, but we don't see any traffic on our tool instance. Now let's create a policy to monitor this traffic and send it to our tool instance. We will give policy a name, demo, append the desired route to the policy. In our case, we will use ICMP. We then select the workload that is to be monitored. We can filter the workload that we want to monitor on the controller. Next, we select the tool instance where traffic is to be forwarded. And finally, we create the policy. Once the policy has been created, the CloudLight AX agent will replicate traffic from the workload and send it to the CloudLight VX virtual switch over VPC peering. Optional filtering and additional packet modification functions are then done on the CloudLight VX virtual switch, as per the policy defined. CloudLight VX virtual switch then forwards the filtered packets towards the tool. Going back to the demo, now that the policy is created, we can see the traffic on the tool instance which is being forwarded from the selected workload. Now let's go back to our policy and take a look at the stats. We see that filter and delivery interface stats associated to the policy are incrementing. So far, we have seen how BigMon Public Cloud enables and simplifies flow-level visibility for workloads in AWS. However, many of our customers typically have deployments in multiple regions across public as well as enterprise clouds. Multi-Cloud Director is capable of managing all Big Switch controllers, whether in public or enterprise clouds, and offers a single pane of glass for enterprises' hybrid cloud deployment. For more information, take a look at Multi-Cloud Director product video. Thank you.